So remember, the concept of implicit differentiation meant that you cannot easily take the derivative of y because your equation has a bunch of x's and y's in it. So what you have to do is take the derivative implicitly because you can't solve for it explicitly. So let's just remember, if I take the derivative with respect to x of x to the third, I get 3x squared, just like you normally do. Multiply by the power, subtract 1. Easy peasy. When I take the derivative of y to the third with respect to x, yes, you do the derivative like normal, 3y squared. But the chain rule, remember, y is a function of x. There are x's inside of that y, and I don't know what they are. So I still have to take the derivative of that. So I have to put the dy dx here. So remember, this was what you needed to do within the problem. Every time you take the derivative of x, you do it normal. Every time you take the derivative of y, you do it normal, but you multiply by dy dx. Okay, so again, the steps are not too tremendous. This is the most important step of the whole problem, because if you do this wrong, everything you do afterwards would be wrong. You take the derivative with respect to x of both sides, d dx. If the term has an x in it, you take the derivative just like normal. Don't do anything different. If the term has a y in it, you take the derivative like normal, and then you multiply by dy dx. This is the chain rule part. You need this here. If it's got a y and you take the derivative, you must put dy dx, even if you're just taking the derivative of y itself. The derivative of y is 1, but it's 1 times dy dx. So it's very important you do that step right. After you do that step, you're going to have a bunch of dy dx's. You're going to have things without. Everything with a dy dx has to be on the same side. Everything without has to be on the other side. Then you factor out the dy dx, and you divide. You solve. You get dy dx alone. It always involves dividing by whatever was next to it. So remember, if you had something like this, the derivative of y is 1 dy dx. It wouldn't just go away. I'd see something like this. Okay, so these were the steps. This is what you will do every time. This is just a refresher of the lesson we did before. Okay, so here's the problem. We want to take the derivative of this. You have x's and y's all together. This is pretty complex, so remember the first step was to take the derivative with respect to x of both sides, the whole thing. One at a time. Differentiate each term. If it's got an x, same. If it's got a y, you just add on dy dx. So the derivative of x5 is 5x4. Now the derivative of cosine is negative sine. So you're going to switch this, you're going to end up switching. So that you're going to get positive sine y times dy dx equal, okay? Now, be careful. Chain rule, this is e to the u. When I take this derivative, the derivative of e to the 2x is e to the 2x times 2, and there's already a 3 there. So this is going to become a 6 because you have to multiply it by the 2. It's x. The letters match, so you don't have to do anything else. Now this, multiplied by the power, subtract 1, but it's a y. The letters don't match. You're doing the derivative with respect to x. So this gets the dy dx. Now, you got to start trading places. I need all the dy dx's on one side and anything without on the other side. So I'm going to start making my trades. Okay, so here I'm doing the step of switching places. I need everything with dy dx on one side. Everything that does not have a dy dx has to go on the other side. So I had 6e2x there. I took away 5x4. Now, the move was to factor these out. That's why you put them on the same side. Move it to the front. This is the reason these are on the same side. I factor them out to the front. Now the problem is over. My goal is to solve for this. Well, just take this and put it underneath there, and it's done. I tend to skip this step when I'm doing them myself, because it's a lot. These problems involve a lot of writing. I'm hoping we can see this at the bottom. So we'll run through it again. Take the derivative of each term. I should have put arrows. I didn't. Derivative of x5 is 5x4. Derivative negative cos y is positive sine y dy dx, because it's a y. Chain rule. Derivative e to the 2x is 2 e to the 2x multiplied by 3 gets 6. Multiplied by 5 times 3 is 15. Subtract 1 off the power, add dy dx. All the dy dx is on the left. Everything else on the right. Factor out the dy dx from the terms that are common. Divide, and it's over. So this was what implicit differentiation was. And this is how you do it.